Now we are going for a modification of SR again. It is JK flip flop. J and K stands for Jack Kilby, the inventors of the flip flop, which is again a modification of this SR flip flop. So, if I am using a NAND gate flip flop, NAND gate SR, it will be like this. This is a NAND gate S bar R bar flip flop. This is a NAND gate S bar R bar flip flop. If I am modifying the circuit like this, okay, then it becomes a JK flip flop. This is enable or the gate. So this is now a JK flip flop. JK flip flop. So SR, S is replaced by J and R is replaced by K. So the truth table becomes like this. J is there, K is there, output. If J and K are 0, 0, the output is not changed. It means it continues the previous state. If the Q was 0, it continues as 0. And if Q was 1, it continues as 1. If J is made 1 and K is made 0, of course enable should be active. Enable active അല്ലെങ്കിൽ circuit work ചെയ്യില്ല. Enable should be made active, and if J is 1 and K is 0, then the output becomes 1. If J is 0 and K is 1, the output becomes 0. If J and K are made 1, the output toggles. Toggles means if the previous Q was 1, then now the Q becomes 0. And if Q was 0, now the output becomes 1. Correspondingly, Q bar will change. So this is allowed in the case of JK flip flop, unlike SR. And in SR, 1 and 1 input was not allowed, but in JK, it is now a useful property which will be used for using counters. And the input is 1, 1. If J and K are 1, 1, then the output toggles. Of course, enable should be active in all conditions. Enable active ആണ് മാത്രമാണ് സർക്യൂട്ട് വർക്ക് ചെയ്യുള്ളൂ. സർക്യൂട്ട് വർക്ക് ചെയ്യണമെങ്കിൽ enable active ആയിരിക്കണം. This truth table will be followed by the JK flip flop. You can verify it by giving values as we done previously in SR. You can have a simple verification by giving the values here. Okay, so for each one, the output toggles. For each one, the output toggles. So assume that I am using a pulse like this. I am using a clock pulse like this, and the response time of the circuit is this much. Okay. And if the input J and K was J is 0, K is 1. Sorry, J is 1, K is 0. Then the output becomes 1. So at that condition, the output will be 1 always. J is 1, K is 0. The output will be 1 always because J is 1, K is 0. But for the toggle condition, if J and K are 1, and if the width of this pulse is very much more than the response time, അങ്ങനെയാണെങ്കിൽ ആദ്യം if the Q was 0, then during this time the Q will become 1. Again J and K are 1, enable is active, and so again it toggles. So for each response time, it toggles. Okay. So depending on the width of the pulse, it may toggle multiple times. So the output may become unpredicted. Depending on the width of the pulse and response time of this flip-flop, if the width is very much higher, it may toggle multiple times, and so the output may not be predicted. And this condition of JK flip-flop is called race around condition. We call it as race around condition. So for level triggered flip-flops, JK flip-flops, for input J and K 1 1, there is a condition called a race around condition. It means the output gets toggled multiple times depending on the width of the pulse, and so the output becomes unpredictable. So in order to avoid this race around condition, the solution is that we can use a edge triggered flip-flop. Either we can use a positive edge triggered, or we can use a negative edge triggered flip-flop. So if I am using a edge triggering flip-flop of J and K type, then the problem is solved. So J and K works almost perfect. J and K works perfect during a edge triggered flip-flop. Okay. The only drawback was this race around condition, in which the output may toggle multiple times depending on the pulse width, and so we have made arrangements in such a way that the circuit works only in the positive edge or at the negative edge. Okay. And so we have solved the condition like this by using positive edge triggering or negative edge triggering. Okay. So this is the JK flip-flop as well as the gated JK flip-flop. Okay. Also, if I can make a modification of this flip-flop like this also, I am shorting this J and K inputs. I am shorting this J and K inputs, and so if J is made 1, K is also now 1, and so the input is now only one input, and we call it as T input, and the T input is called toggle input. That is, J and K are made 1 because J is shorter to K. So if I give 1 here, this flip-flop works in the toggle mode. If it is 0, the flip-flop is not affected. The flip-flop works in the previous condition, not change mode, and so this T responses only for the input 1. So this is a toggle flip-flop. Likewise, if I am shorting this using a NOT gate, it becomes a D flip-flop. അതായത് SR ഫ്ലോപ്പ് നമ്മൾ എസ് നോട്ട് ചെയ്ത് ആറിൽ കൊടുത്തപ്പോൾ ഡി ആയതുപോലെ ജെ നോട്ട് ചെയ്ത കെയിൽ കൊടുത്താൽ it again becomes D flip-flop. So if J and K are shorted directly, it is called a toggle flip-flop, and if J and K are shorted through a NOT gate, then it becomes a D flip-flop. So D can be created either by using SR or by using a JK, while T can only be created using a JK flip-flop. Okay. So these are the 4 types of flip-flops: SR, JK, D and